Okay, today's lesson we are looking at trigonometry, and we're going to start by just an intro to trigonometry and the trig ratios. So we did already watch this video here, an intro to trigonometry, and we kind of looked at some usefulness of trigonometry. So here is just an example of if you were trying to figure out the length of a tree, you can use a clinometer to figure out this angle here to the top of the tree. And if you know the distance you are standing from the tree, we are able to use trigonometry to figure out the height of a tree. So let's go over some terminology, so some important terms for right angle triangles. Firstly is the right angle. We know where the right angle is because of the little box in the corner. This always represents a right angle, which is a 90-degree angle. Another angle that we usually know in these types of questions is one other angle here. In this example, it is shown as theta. This symbol here just represents theta. We always know the hypotenuse. This is the longest side, and it's always the side opposite the right angle. So right across the right angle is the hypotenuse. It's also the longest side. Now are the two other sides based on where your angle, the known angle is. So this is our angle here, theta. Across from that angle is the side called the opposite, and beside that angle is the side called adjacent. Adjacent means beside. All right, so now based on this angle here, we know that this is opposite, this is adjacent, hypotenuse always stays the same. Hypotenuse is always found across the right angle. All right, so next we'll start looking at the ratios. So there are three ratios. They are called sine, cosine, or tangent. In brackets, we have abbreviations. So SIN represents sine, COS is for cosine, and TAN is tangent. I will show you the table. There's a chart I can show you, but we will also be using our calculators. All right, so we can use these three ratios to determine the angle size or the length of the sides in a right angle triangle. So let's look at our first ratio, and we're basing our ratios on this angle here. This angle is called alpha. So sine alpha, this is alpha here, this angle. So sine alpha is opposite over hypotenuse. So this is our hypotenuse, okay? This is our opposite, and this is adjacent, based on this angle alpha. All right, so again, right across the right angle is the hypotenuse, across from alpha is opposite, and beside the angle is adjacent. All right, so our first ratio is called sine. Sine, the ratio for sine is opposite divided by hypotenuse, so therefore side A divided by side C, shown here. Cosine theta is the side adjacent, so side B divided by hypotenuse, so side C, so B divided by C. And tangent ratio is opposite divided by adjacent. All right, so opposite is A, adjacent is B, so therefore A divided by B. All right, then we could use the table or we can use our calculators, and either of these ratios, we can find the length of either of the two missing sides. All right, so here, again, we've just learned our three ratios for sine, cosine, and tangent. All right, so just to review those three basic functions in trigonometry, the three basic functions, sine, cosine, tangent, these are the abbreviations. The sine ratio is opposite divided by hypotenuse. So here is theta, so opposite divided by hypotenuse. Cosine ratio is adjacent divided by hypotenuse. And then the tan ratio is opposite divided by adjacent. There is a way to remember that. It's an acronym called SOHCAHTOA. So SO, S-O-H, stands for S for sine, opposite is O, and H is hypotenuse. So sine theta is opposite divided by hypotenuse. So this was the hypotenuse, there's the opposite, and there's our angle theta. Cosine, C represents cosine, A for adjacent, H for hypotenuse. So adjacent divided by hypotenuse. So here's our angle theta, here's adjacent, here's hypotenuse. And lastly is our tan ratio. Again, our angle theta is there. Here's opposite, here's adjacent, and our ratio is opposite divided by adjacent. So SOHCAHTOA is one way to remember those three trig ratios for sine, cosine, and tangent. Okay, so our first example, we need to write out the sine, cosine, and tangent ratios for this triangle. So sine of alpha, so there's alpha, and I'm just going to write out our acronym here, SOHCAHTOA. So for sine, we know it's opposite divided by hypotenuse. This is our hypotenuse. That doesn't change. The hypotenuse is always found across the right angle. In this case, it is 13. So when we're looking at angle alpha, and we're trying to figure out our sine ratio is opposite divided by hypotenuse. So opposite is 12, and hypotenuse is 13. So there's our ratio, 12 over 13. Okay, if you can reduce it, you would, but we can't in this case. We're leaving it as 12 over 13. Next is our cosine ratio. Our cosine ratio is adjacent divided by hypotenuse. This is our adjacent side, so it would be 5 over 13. And lastly is tan of alpha. Tan is opposite divided by adjacent. Opposite is 12, and adjacent is 5, so our ratio is 12 over 5. All right, so those are our three ratios for this triangle. All right, so when we're looking at angle beta, which is here, the sine of beta would be opposite and hypotenuse. The opposite of beta is 5. All right, and then the hypotenuse doesn't change. Hypotenuse is still 13. So it would be 5 over 13. All right, so for when we look at beta, this is its opposite, and 12 is its adjacent side. Hypotenuse stays as the hypotenuse, it's still 13. Okay, so for cosine beta, adjacent is 12, and then hypotenuse is still 13, so 12 over 13. And lastly, tan of beta would be opposite over adjacent, so therefore 5 over 12.